Assalamu alaikum, brothers and sisters. Welcome to the journey of quest where we quench your thirst of knowledge. Ever wondered how scientists get to know about the history of our planet? One word: isotopes, specifically stable isotopes. But what exactly is an isotope, you might ask? Well, in the simplest terms, isotopes are versions of the same element with different numbers of neutrons. Now, these isotopes can be either stable or unstable. The difference? Stable isotopes do not decay over time, they remain as they are, thus the name stable. And why are stable isotopes so important, you may wonder? The answer lies in their stability. Because they don't decay, they can be found in nature long after they were formed. This gives scientists a kind of time capsule that they can study to learn about the past. They provide crucial insights into a wide range of scientific fields, from geology to climatology and even archaeology. So to put it simply, stable isotopes are versions of elements that have withstood the test of time, and they are invaluable tools for understanding Earth system processes. Stable isotopes may sound complicated, but they aren't. It's all basic chemistry and physics at work. Imagine you're at a family reunion. Everyone shares the same last name, but each person has a unique first name. Now let's think of elements in the same way. All atoms of an element share the same number of protons, like a family last name, but they can have different numbers of neutrons, like the first names in a family. These variations are what we call isotopes. Now, just like some family members might be more robust and live longer, some isotopes are more stable than others. The stability of an isotope comes down to the balance between protons and neutrons in its nucleus. When this balance is just right, the isotope is stable and it doesn't change over time. But when the balance is off, the isotope is unstable or radioactive. These isotopes try to reach stability by releasing energy in the form of radiation, which can change the number of protons or neutrons and thereby transform into a different element altogether. Let's take carbon, for instance. Carbon-12 with 6 protons and 6 neutrons is stable, but carbon-14 with 6 protons and 8 neutrons is unstable. Over time, carbon-14 loses 2 neutrons and transforms into nitrogen-14. So why do some elements have stable isotopes while others don't? It's all about the magic number of neutrons. For lighter elements, the magic number is often the same as the number of protons. But for heavier elements, the magic number is usually greater than the number of protons. This is why heavier elements often have more isotopes than lighter ones. In a nutshell, isotopes are just variations of elements with different numbers of neutrons. The balance between protons and neutrons determines whether an isotope is stable or not. And it's these variations that allow us to use isotopes in a wide range of applications, from medical imaging to understanding Earth's climate history. So, while the number of protons defines an element, it's the number of neutrons that can make all the difference. Now that we understand what stable isotopes are, it's time to explore how they help us understand Earth system processes. Stable isotopes are like secret agents, infiltrating every corner of the Earth, from the deepest ocean trenches to the highest mountain peaks, and even into the atmosphere. They're not just hanging out, though. They're busy recording data about their environments, waiting for scientists to decode their messages. Take climate change studies, for example. Oxygen isotopes in ice cores, extracted from the polar ice caps, carry a record of past temperatures. By analyzing the ratio of oxygen-16 to oxygen-18, scientists can infer the temperature at the time each layer of ice was formed. This offers a window into climatic conditions tens of thousands of years ago, long before humans started recording weather data. Stable isotopes also help us understand the Earth's crust. In rocks and minerals, the ratio of certain isotopes can reveal the conditions under which they formed. For instance, the ratio of strontium isotopes can tell us about the age and composition of the Earth's crust, while the ratio of lead isotopes can shed light on the history of our planet's tectonic movements. And it's not just about rocks and ice. Stable isotopes can even help us track the migratory patterns of ancient animals. Carbon and nitrogen isotopes found in ancient bone and teeth can indicate an animal's diet and the type of environment it lived in. This information can then be used to infer where the animal migrated during its lifetime, giving us a glimpse into ecosystems of the past. Stable isotopes are truly the unsung heroes of Earth system science. These tiny particles, quietly doing their work in every corner of the planet, are key to unlocking our understanding of the Earth's past, present, and future. They help us piece together the Earth's history, from shifts in climate and tectonic activity to the movements of ancient creatures. Stable isotopes thus serve as time capsules, providing insights into the past and helping us predict the future. From climate studies to forensic sciences, stable isotopes have a wide range of applications. Let's dive into some real-life examples where these little atomic wonders make a big difference. First up, climate studies. You see, stable isotopes are like nature's time capsules. They're found in ice cores, tree rings, and sediment layers, holding on to clues about our planet's climate history. By studying the ratio of oxygen isotopes in ice cores, scientists can piece together a picture of Earth's past temperatures. It's like having a history book written by the planet itself. But that's not all. Stable isotopes also help us understand current climate patterns. They're used to track the movement of water through the atmosphere, giving us insights into the complex dance of evaporation and precipitation that drives weather around the globe. Next, we move from the sky to the ground, where stable isotopes serve as nature's detectives, helping to track water sources. By studying the isotopic composition of water, we can trace its journey from the clouds, through rivers and groundwater, right down to your tap. This is crucial in managing water resources and ensuring sustainable practices. But what about when the detective work gets a little darker? That's where forensic sciences come in. Stable isotopes are like silent witnesses at a crime scene. For instance, the isotopic composition of human hair can reveal a person's recent geographical movements and diet. It's a powerful tool in solving mysteries and bringing justice to light. And these are just a few examples. Stable isotopes are also used in agriculture, medicine, archaeology, and more. From understanding how nutrients move through ecosystems, to dating ancient artifacts, to developing new medical treatments, stable isotopes are truly the unsung heroes of science. Indeed, the applications of stable isotopes are as diverse as the isotopes themselves. Stable isotopes, tiny as they are, play a huge part in helping us understand our planet. They are the unsung heroes of science, the microscopic detectives that allow us to unravel the mysteries of Earth system processes. Let's take a moment to recap the fascinating journey we've just taken through the world of these minute marvels. We began by introducing you to stable isotopes, these infinitesimal entities that form the basis of much of our understanding of the world. Despite their size, they have an impact that is anything but small. They are the keys that unlock the secrets of the universe, the tools that scientists use to decipher the past, understand the present, and predict the future. We delved into the science behind stable isotopes, exploring how they work and why they are so important. We discovered that they are like nature's fingerprints, unique and telling, providing us with invaluable information about Earth system processes. Their ability to remain unchanged over time makes them the perfect tools for scientific investigation. From there, we looked at how stable isotopes are used to understand Earth system processes. We learned how they can tell us about climate change, atmospheric conditions, geological formations, and so much more. They give us insights into the Earth's past, allowing us to piece together the history of our planet in a way that would otherwise be impossible. And then we explored the real-world applications of stable isotopes. From helping us track pollution to improving our understanding of the food web, these tiny powerhouses are making a big difference. They are improving our world in ways that are tangible and real, proving that size doesn't always matter when it comes to making an impact. So, as we draw this journey to a close, let's take a moment to appreciate the incredible power and potential of stable isotopes. These microscopic time travelers are more than just scientific curiosities. They are vital tools in our quest to understand and protect our planet. Next time you think about the history of our planet, remember the role of these microscopic time travelers, the stable isotopes. Thanks for watching us share our videos, subscribe our YouTube channel, and press the bell icon and stay curious for new uploads.